F prime equal to 0. And the one that people keep forgetting on their derivative quiz is F prime undefined. F prime equal to 0 or F prime undefined. The function that we have already is F prime. And if we tried to solve this function by hand, we would not be able to solve it by hand. And so the creators of the AP test, again, they're pretty smart people, and they know how to force you into using the calculator. So this is a calculator question for a reason. On the calculator portion of the test, I think there's 15 questions. And of those 15 questions, I think like maybe 5 or 6 of the questions are actually calculator active. So maybe another skill that goes along with the calculator is knowing when to use the calculator and when not to use the calculator. Okay. So let's type this function into y1. This is going to be cosine squared. Everything on the AP test is in radian, so we definitely want to make sure that our calculator is in radian mode before we start graphing a trig function. And the calculator is always going to do the right order of operations. So if I type it in like this, the calculator is going to do the division for both terms first and then do the subtraction. If you're uncomfortable about that, then use parentheses. Make sure I'm in. So I'm in radian mode. And then what is it that I want to see for this function? So, but we're already looking at f prime. So I want to see the zeros. So then I'm not going to go straight to graph. I'm going to go to the window. And what x's do I want to see? 0 to 10, which is given. So 0 to 10. And if we want to extend that out a little bit more, then we can go -1 to 11. But 0 to 10 is the interval we're looking at. What y values do I want to see? We only want to see 0. So we want to see where the function that we typed in, which is f prime, is equal to 0. So then I'm going to put my y min and y max as -1 to 1. And if I put my y min and y max as -1 to 1, then when I hit graph, what I see right in the middle of my graph is the y value that I'm interested in, which is the y value where f prime is equal to 0. We're looking to see are there any values between 0 and 10, not including 0, not including 10, where f prime is either equal to 0 or undefined. How many values does it look like we have that? It looks like 3, and then it looks like this one point where we're not quite sure if that point is touching the x-axis or not, so then we're going to adjust our window. Let's adjust our window to be -0.5 to 0.5, so that we zoom in a little bit, and if this is not good enough, then we can zoom in a little bit more. And so now we can tell that that other point is not touching the x-axis, so there are 3 points where f prime is equal to 0. All of these questions that are on this worksheet, they came from an old AP test. So the answer here then is B. Keep going. Okay, the next one, derivative is given. It says, what's the x-coordinate of the point of inflection? So then, this is f prime. How would I figure out what is a point of inflection? Somebody said it over here. Concavity changes. So f changes from up to down or down to up. What would be happening for f double prime if the concavity is changing? Positive to negative or negative to positive. So a change in sign. Are we looking at f double prime? So either we're going to derive f prime to turn it into f double prime. Why would we not want to do that here? Like, how would we derive this? Quotient rule. And so a lot of work to do quotient rule here. So how can we tell a concavity change for f prime? increasing to decreasing, or decreasing to increasing. So then let's type in f double prime, or f prime, to our calculator. And before I hit graph, I'm going to go to the window. And what x values do we want to see? Negative 0.5 to 1. Why do you say that, Hillary? Because we're looking for an x coordinate, and there's the answer choices that are x coordinates, and the smallest x coordinate they have is negative 0.2. So negative 0.5 as a left endpoint, and as a right endpoint, Hillary said 2. The largest x value they have there is 1.008, so 2 seems like a pretty good endpoint. So again, maybe being a little bit conscious about thinking about these are x values, about thinking about what x's we want to see rather than just typing in and hitting graph. Do we know the y values that we want to see? So we don't know the y values that we want to see. On this calculator, when you set the domain, when you set the x range, if you hit zoom, I think it's zoom 0, which is zoom fit. Is that zoom? Yeah. Zoom fit, zoom 0. That adjusts the range to the domain that you input. So we input that domain that was from negative 1 to 2, and the calculator said these are the y values that you should look at between negative 1 and 2. And if we don't agree with their range, then at least it gives us a starting point to adjust from. So like they say, from 0.07 to 0.4. If we don't like that, then let's say negative 1. Negative 1 to 1. At least that way we get to see the x-axis. But at least that gave us a starting point for what to look at. Okay, so we're looking for increasing to decreasing or decreasing to increasing. Do we have that happening here? Increasing to decreasing, how are we going to find that? Increasing to decreasing, how are we going to find that relative max for the derivative? We're going to calculate. So we're not going to trace, we're going to calculate. So second, calculate is above the trace. What are we calculating? A max. And we need a left boundary. So we can either scroll to the left boundary or we can type in the left boundary. What might be a good lower boundary for the x here? 0. So x equals 0 as my left boundary. And a right boundary? 1. And then there's only one max, relative max between 0 and 1, so the guess doesn't matter. If there was multiple relative maxes, then the guess would matter. So we get this number, 0.472, and that's answer choice B. Questions about that one? How do we find the max? Is that what you're saying? So second, calculate. We're calculating a max, so option 4. And then I need to type in, I need to tell the calculator, look between these x values. And we can type in those x values, or we can also scroll to the left of where we think the max is and scroll to the right of where we think the max is. Sometimes it's easier to type, sometimes it's easier to scroll. In this case, it seems pretty obvious that the max is between 0 and 1. So that's my left boundary, x equals 0. as my right boundary, x equals 1. And then the guess, since there's only one relative max between 0 and 1. Is that good? Here's two functions, f and g. At what value of x do the graphs of f and g have parallel tangent lines? What are they asking for here? Parallel tangent lines. Where their slopes are what? The same. So how would we find their slopes? The derivative. So let's find f prime. And let's find g prime. What's f prime? Six e to the 2x. The derivative of e to the power of is e to the power of, leaving the exponent alone, times the derivative of that exponent, which is 2, and then we have that constant multiple 3. What about gx? 18x squared. And then what we want is to set these two things equal to each other. Then what? So solve for x, and so we can divide by 6. What does that give us? And then if we take the natural log, let's get over here. If I take the natural log of the left side, what's left? And then on the right side, natural log of 3x squared. And then? We still have an x. What's the exponent on the square? So then if we take that exponent out, that exponent also has to be applied to the 3. So not that we can't do that, but we can do that. Moving the exponent here, though, doesn't really help us all that much. Okay, so we took the exponent out. That's not the issue. What's the issue? We still have that x. It's a calculator problem. And we should be solving it using the calculator. So how can we find where these two, for what x value these two functions have the same y value? Where they intersect. So that's why it's a calculator problem.
Do you put the f of x or you put f prime?
Well, what equations do we want to be equal to each other? We want the derivatives to be equal, because we want to know at what x do these two functions have the same slope for their tangent lines. So we need f prime to equal g prime. Even if it's that simplified, we can put 6e to the 2x equals 18x squared. We can put e to the 2x equals 3x squared. Algebraically, those are the same. So on one side of the equation, I'm going to put into y1. So e to the 2x. And the other side of the equation, I'm going to put 3x squared. And before I hit graph, I'm going to hit window, and I'm going to think about what x's I want to look at. What x's do I want to look at? -1 to 0 for the x's. Do I know what y values I want to look at? We can do zoom fit, so zoom 0, and we'll see how that works out. That point of intersection is the point that we're looking for. So how are we going to find that point of intersection? Second, calculate. Finding the point of intersection, so option 5. Students always do more than they need to here. They always start scrolling, but the calculator is asking you a question. It's saying, is e to the 2x, that's y1, Is this the first curve that we're finding the intersection of? Yes, and is this a point on the first curve? Is there a defined x and y? So you just have to hit enter. You don't have to scroll at all. Then y2, is that the second curve that we're finding the intersection of? And do I have a defined x and y? And then it asks to make a guess. If there's more than one point of intersection, then the guess matters. If there's more than one point of intersection, whichever guess we have closer to that point of intersection, that's the point of intersection that we get. When there's only one point of intersection, just hit enter. And there's the x value that we're looking for. Yes, ma'am. I didn't know what y values to put, so then I put zoom 0, zoom fit, and the calculator adjusted to the right y values. Is that okay? I think you typed them in wrong, or you put the wrong x values. Are x values from -1 to 0? You're good now? I want to talk about one alternative here, and that alternative is, again, algebraically, we have e to the 2x equals 3x squared. Is that algebraically the same as e to the 2x minus 3x squared equals 0? The reason why I might want to solve this equation versus the intersection method is when I type in e to the 2x minus 3x squared, and when I change my window for the x's is still going to be -1 to 0. And now I don't have to let the calculator figure out the y values for me. I don't even have to guess at the y values. The y value that I want to see is a y value of 0. So then I can type -1 to 1. Hit graph. Now we're looking for a 0. We're looking for that x-intercept. Second, calculate. We're not tracing, we're finding exact values. And this time I'm finding a 0, so option 2. The left boundary is -1. The right boundary is 0. And there's only 1, 0. It's that same x value. So I give up a little less control to the calculator here because I know what y values I want to look at. Versus that point of intersection, I don't know what y value where those two graphs are going to intersect, so I have to ask the calculator, can you tell me what y values to look at? Whereas here I'm telling the calculator, I want to look from -1 to 1, because I want to see that x-axis. So when I'm calculating, is that your question? So when I hit second calculate, and I'm finding the 0, so that's option 2. And then it's asking me for the left boundary. I'm just typing in like -1. Just straight typing in, enter. Asking for the right boundary, I just typed in 0. Enter. I don't know if y'all recall this or not, but we did this in pre-cal where we looked for points of intersection and we looked for zeros to solve equations, exponential equations, log equations set equal to polynomials. Can I keep going? For what value of x is the slope of the line tangent to the graph equal to 3? So what are we solving here? What do we need to do with this? This is y'all's next one. Okay, so particle moves along the x-axis, so at any time the velocity is given by this function. What's the acceleration at t equals 4? So without calculating yet or without doing anything yet, what's the process that we would do to find the acceleration at t equals 4? We would take the derivative of velocity, which would be v prime of t, and then what would we do after that? We'll plug in 4. So v prime of 4. Can we take the derivative of this function? Is this a function that we know how to take the derivative of? Wow. Yes. Yes, we do. The derivative of a constant 3 is 0. Constant multiple of 4.1, the derivative of cosine is negative sine, leaving the inside alone, times the derivative of that inside. Okay. Yes, we do know how to take the derivative of this function, or we should know how to. I'll put this on y'all's next test. But whenever we want to take the derivative and plug a number in, the calculator will do that. Numerical integration is math 9. Numerical derivatives is math 8. Math 8. We want to take the derivative with respect to x, and we're just going to replace our t's with x's, of 3 plus 4.1 cosine of 0.9x. And after we take the derivative of that function, we want to evaluate that at x equals 4. Just typed in the function. Answer choice C. We okay with that? So a couple of things. When we're on the calculator portion of the test, we want to be conscious of when we use the calculator, or when we can use the calculator, and when we have to work by hand, or when it's faster to work with the calculator versus when it's faster to work by hand. If we want to take the derivative of something that's even mildly complex, when I want to take the derivative and plug in a number, the calculator can do that for you. They're not going to check your work on the multiple choice part of the test, so all we care about is the answer here. The other thing is solving equations. If we're solving equations on the calculator portion of the test, we should be able to solve equations with the calculator as well. Whether that's by getting one side of the equation equal to 0 and finding the zeros of that resulting graph, or whether it's using the points of intersection. Both of those methods should work. Okay, then back to your number 5. This one we have this function f. We want to know for what x value is the slope of the line tangent to the graph equal to 3. Slope of the tangent equal to 3. What are we going to do? F prime equal to 3. So f prime of x equals 3. So stuff that we've already done, right? We're just adding the calculator element to it. What's the derivative of this function? 16x e to the 4x squared. The derivative of e to the power of is e to the power of, leaving the exponent alone, times the derivative of the exponent. Good. How are we going to solve that equation? We can subtract 3 and we can plug that into the calculator. In this case, so where I really wanted to use that method of having one side of the equation equal to 0 was the problem before, because I have a function on both sides, a function with changing y values on both sides. Do I know what y value I want to see for this question? I want to see a y value of 3. So there's not that same kind of ambiguity about what y values are these functions intersecting. These functions are intersecting at a y value of 3. But what Laquavius is saying is not wrong. We also could use that method as well. So y equals, I'm going to type 16x e to the 4x squared. Into y1, and I'm going to type 3 into y2. Then I'm going to adjust my window. What x values do I want to see? 0 to 1 is fine. What y values do I want to see? From 2 to 4. I want to see that y value of 3. So then I'm looking at y values from 2 to 4. And then graph. There's the exact point that I want to see there. Y equals 3. But you asked and people are answering. Was anybody who answered, were you angry at her for asking? Second, calculate. We're going to calculate an intersection. Is this the first curve? And is there a defined x and y? So then enter. Is this the second curve with a defined x and y? And then the guess doesn't matter because there's only one point of intersection. Which is answer choice A. If there's a reason that mine looks different than yours, it's because y'all have the revised one, because there used to be 5 answer choices on the AP test. Now there's only 4 answer choices. Anybody have a question about the last one? Move on. All right, so here this derivative of this function is given. And it says, where does f have a relative max? Can we turn this function back into the original function? So how do we turn f prime back into f? But the problem if we do the antiderivative here is that we're going to have a plus c, and we don't have a point on the original function to solve for that c. So is there a way that we can tell where a function has a relative max from its derivative?
Yes.
What does a relative max for f look like? Not for f. For f, increasing to decreasing. For f prime, positive to negative. So we want to see where this function f prime changes from positive to negative. Y equals, let's type in f prime. And then before I hit graph, I'm going to hit window. And what x's do I want to see? Negative 1 to 1. What y values do I want to see? If I'm looking for the points where my graph changes from positive to negative, we want to see where y equals 0. We want to see the x-axis. Because if y values change from positive to negative, they have to cross the x-axis. Negative 1 to 1. That's why we're always setting the derivative equal to 0 to find the critical points. Because the critical points are possible relative maxes and relative mins. And in order to be a relative max or relative min from the derivative has to change from positive to negative or negative to positive. And to change from positive to negative to change from positive to negative or negative to positive, the graph has to cross the x-axis. So it has to cross that value of 0. There's 2 points, right? There are 2 points, but only one of those is the point that we're after. We're looking for the values to be going from positive values to negative values. And the point that's on the left here is negative to positive. So the point on the left represents a relative min. It's the relative max that we want. So this time the guess is going to matter, or the interval is going to matter. We're going to calculate, what are we going to calculate? We're going to calculate a 0, and what boundaries are we going to put? 0, something way over there, which is what? It's 1. And then the guess, there's only 1 0 between the 0 and 1. So the guess doesn't matter here. 0.91. I don't think I have this one. All right, I don't have this one on my paper, but it says the derivative of a function is given by f prime on what intervals from 0 to 9. On what intervals is f decreasing? This is going to be number 7. How would I know if f is decreasing? F prime negative. Like, graphical analysis is a huge part of the AP test, and I feel like for these graphical analysis type problems, is there a point to concavity? Is the function concave up or concave down? Is f increasing or decreasing? That we should be drawing the fun chart over and over again, or at least the piece of the fun chart that we need. So if we need f prime to be negative, then what will we do with that graph of f prime e to the sine x minus cosine x minus 1? Well, we want the derivative to be negative, and we already have the derivative. We just want to see where that function is negative, so plug it into y1. From 0 to 9, how come 0 to 9? That's the interval that's given. And then what y values do I want to see? We want to see 0. We want to see where this graph is negative below the x-axis. So y values, negative 1 to 1 seems fine. And if it's not fine, then we'll adjust it. And we're looking for negative values for this graph. And so we can already, it looks like we can already get rid of some values. Is that true? I think we can solve this without even solving for those values. Has to be A. What's wrong with C and D? They don't start at 0. The first interval where this graph is negative starts at 0. So C and D are gone, and then what's wrong with B? It's going to 1.9, and we're negative from 0 to some value that's less than 1. Okay, let f be the function with derivative given by f prime equals sine of x squared plus 1. How many relative extrema does f have on the interval from 2 to 4?
2.
This is number 7? Oh, what is this one? Particle. I don't have this one yet. Do I have this one? I didn't check because I thought it was the same. Okay. So, what's the velocity of the particle when the acceleration is 0? What do we want to do here? Take the derivative twice. So this is the position function. We want the second derivative. Are we taking the second derivative and plugging in a number? So this one we have to take the derivative by hand. So we're going to differentiate what's s prime. This no, don't tell me. Find the second derivative of this function. Venus set off the fire alarm. Everybody okay with this? So this is my acceleration function. Where might be the mistake in taking the derivative? The 1/2. Okay. Say it again. I think also maybe the signs with the SIGN signs of the SIN sines and cosines. And we want to find out what the velocity is when the acceleration is 0. So here's our acceleration function. What are we going to do with it? Set it equal to 0. So acceleration, just 4 cosine t minus 1 equals 0. And then how are we going to solve that equation? Plug it into the calculator. Even if we try to solve algebraically, add 1, divide by 4, cosine of t equals 1/4. What angle on the unit circle has as its x-coordinate 1/4? Is that a special angle that we know? It's not. So then, even in that case, we still need the calculator. So, using the calculator, 4 cosine x minus 1. I'm not going to hit graph, I'm going to hit window. And what x's do I want to see? 0 to pi. That interval is given. What y values do I want to see? I want to see 0, so negative 1 to 1. And then graph. And there's the point that I'm looking for. So we're going to calculate. What are we calculating? That's my left boundary. 1. That's my right boundary. 2. And the guess doesn't matter because there's just 1 0 between 1 and 2. Is this the x value that we're looking for? Or is this the answer? Let me say it that way. It is an answer choice, right? But it's not the answer to the problem. This is t equals 1.318. Is that what it is? Okay. But this question's asking for the velocity when the acceleration is 0. So what do I want to do with this value? Plug it into s prime of t. Okay, so another thing with this calculator, when you solve for something on the graph menu, that value is automatically stored to x. So there's that 1.318. So when we plug this in, also on the AP test, it doesn't say this on every single problem. It says this on the directions at the beginning of the test. You're not supposed to round any numbers until you get to your final answer. So if we're going to use this number in the problem, we're not supposed to round it. We're supposed to use all those decimal places. And in order to avoid typing all of that in, if this number is stored to x, every time we type x, we get this number. So instead of typing 4 sine and then rounding that number, we're going to type 4 sine of x minus x. And the calculator is replacing x with that number that's stored in x. And here's the answer that we're after. If we want to store a different value into x, then like if you hit 4, store is right here. And then x. Now every time I type x, I get 4. And if I go and I recalculate that same equation with a different value stored for x, now I get a different number. So we're going to be doing this a lot where we have these values, these decimal values, and we want to use them over and over again, but we don't want to keep typing them over and over again. So then we'll store them to a variable. And every time we solve for something on the graph menu, whatever we solve for automatically gets stored into x. Okay, now we're at this relative extrema problem. What does relative extrema mean? Maximum or minimum. So relative maximums or relative minimums. Extrema, extreme points. So those extreme points are max values and min values. So how would I know where f prime has a relative max, or how would I know where f has a relative max or relative min? So if f goes from increasing to decreasing or decreasing to increasing, how do I know from f prime whether I have a relative max or min? Positive to negative or negative to positive. So then type this function into y equals sine of x squared plus 1. Let's check our window. 2 to 4, that's the interval that's given. And the y's, negative 1 to 1. We want to see where f prime is changing from positive to negative or negative to positive. And in order to change signs, the graph has to pass through the x-axis, has to pass through y equals 0. 1, 2, 3, 4 times. 4 times that the graph is changing signs here. Answer is D. All right, last one. Equation of the tangent line. What do we need for equation of a tangent? A slope and a point. A point and a slope. We already have the slope. The slope is 1. What we don't have is the point. So what do we do here? Take the derivative. Okay. F prime of x. (4x cubed plus 4x) set that equal to 1. Set it equal to 1 because we want f prime to equal 1. How would we solve that equation? Put it in the calculator. Yes, 2 different y values on the calculator. Find the point of intersection. Definitely somebody on the AP test is going to try to solve this equation. Okay. Algebraically, it's calculator, so it's a calculator portion for a reason. Do we know what x's we want to see here? We don't. So if we don't know, then this is a guess. So I'm going to guess the default window -10 to 10. If that doesn't work out, then we can adjust it. But it is a guess. Do I know what y values I want to see? 0 to 2. And 0 to 2 because we want to see that y value that is the slope of 1. So maybe our interval for x's wasn't all that great, but is there a point of intersection here? And that's all we care about, that we see the point of intersection. We're going to calculate a point of intersection. Is this the first curve?
Yes.
And is this a defined x and y? Enter. Is that the second curve with a defined x and y? And then the guess doesn't matter because there's one point of intersection. And this is what? This is the x. This is 0.236. And I'm rounding on my paper, but I'm not going to round in the calculator. What do I want to do with that x to find the y? Plug it into the original. Going back to the calculator screen, that value that we just solved for on the graph menu is stored in x. And I want to plug that not into the derivative, but into the original function. So x to the 4th plus 2x squared. This is 0.115. And then how am I going to turn that into the equation of y? So y equals the slope times x minus that x coordinate plus that y coordinate. And when I distribute the 1, then I get x minus 0.236 plus 0.115. And then if we want to not round here, then we could say negative of this number plus that number. And I just scrolled up and copy and pasted into this line. So then the y-intercept that we're looking for is at negative 0.122. Probably would be okay to round here for intermediate values, but especially on the free response portion of the test, we don't want to do any intermediate rounding. Yes? I put negative. I want the negative of that 0.236. So the negative of that 0.236, which also is stored in x. So I just could have typed x, but I scrolled up to that 0.236 and I hit enter. And then plus, and I scrolled up to the 0.115 and I hit enter. And then that's the y-intercept that we're looking for. Yeah. Is that good? Let me stop this recording and see how this worked out.